All right, everyone. So now we're going to be showcasing pretty much why object-oriented programming and class development is extremely powerful by using this concept of inheritance. And different languages do this a bit differently, but for Python, we're going to start by just developing our own human class and then trying to implement that student class after it. So I'm going to create a class that's just called human with capital H, and it's going to inherit from the object class. Now, again, object is this basic class. It doesn't actually do anything. This is kind of redundant if you leave it blank, but again, it's proper order to just leave it as object. So again, this doesn't do anything new to us really. It's just what we will do. And what I'm going to do here is I want to create my constructor. So again, whenever you create a custom class, you're going to create a constructor, a part of that class for the most part. And my constructor definition again is with my 2 underscores in it for initializer, then 2 underscores after it. I'm going to take in myself. And now what I want to do is to try to develop a bit about what I want my human class to do. So what I'm going to say here is I'm just going to make this really basic where I say self.hair color. So I want a hair color attribute. And then I also want an attribute like self.eye color. Let's just do hair color and eye color. And now what I'm going to do inside of my constructor is I'm just going to go ahead and create the hair color and brown color to be default attributes as well if I don't provide anything for them. So if nothing's provided, I'll just go with what I have here. So brown hair and blue eyes like so. So now if I have this as my default item, I'm going to say down here, my self.hairColor attribute or a variable, I should say, is equal to hair color, and my self.eye color is equal to eye color. So again, what I could do now is to just test this incrementally, and what I'm going to say is a is equal to human, a.eye color, let's see if this is there, blue, a.hair color, and that one's there as well with brown. Now, right now, our class doesn't really have any functionality with it, so what we could do here is I can use some setters and getters. So I could say something like def of set eye color, like so. And what I could say is it's going to take in a self. And what I'm going to say here as well is I'm going to say, okay, let's go ahead and take in hair color, or excuse me, eye color. And now I'm just going to replace my self.eye color with the eye color that the user provides. And I can do the same with my hair color here as well. Let's say set hair color, self hair color. So self.hair color is equal to hair color. Nice. So now I have my two setters here, and now I also can use my getters as well. I'll just do the hair color getter for the time being. You can add one for eye color if you'd like. But again, in difference to the set, if we're getting something, we're just going to be returning it to our users, so we don't actually need a parameter besides self. Nice. So, very basic class. Let's see if we can do two more things here with this one. Let's just see if this is all working for us. So a is equal to human, a.get eye color. Oh, I meant to say hair color because I didn't do the eye color one. Nice. So I get it as brown, and then I could say a.set hair color. Let's say dyed my hair like black or something. There we go. Nice. So now my hair color is up to be black. So this is something that's a bit different here, but our class seems to be working okay. We have our default parameters working. They're set up, and we can provide them with different ones or just use the default ones. Now, what I want to do here is very briefly implement two overloading operators where I go ahead and try to change around these things. And what I could say here is I'm going to overload the string operator with self, and I'm going to return the string representation of where I say human object with hair color. I'll say with blank hair and blank eyes. And I'm going to format this guy by saying self.hair color and then self.eye color. And I'll full screen this for the time being. And now what I'm going to do here as well is I'm going to overload the canonical string representation of self, and I'm going to also return human object, hair, blank eyes, like this. So I'm going to say human object, brown hair, blue eyes, or something like that. And then I'll format this to say self.hair color, self.eye color. Great. So now we're getting through this and it's looking okay. And now the next thing that we want to try to do here is I want to also implement this thing where I can overload an operation of this. So right now, let's just try to make this a little bit more complex once we add in a student. And before we do our inheritance, let me try to do... Actually, let's just try using the student for the time being. So right now, let's just say that I have a new class called student. Let's double check this is all working for us. So a is equal to human, print a, nice. And if I type out a, human object, so great. So now we have our human working okay. And what I'm going to say next is I want to create another object, but let's just say that all our students have eye color and hair color. And I could say here is def of student. And what, oh, excuse me, not def, class student. And what did we always say happens inside of here? This is where we actually inherit from something else. So if I want to inherit from the human class, what I'm actually going to do here is say student, and then inside of those parentheses, put the class called human. Now, what does this do for us? There's going to be a few more things that we need to do before we can run this code. If I just type pass in here, let me try to do something here. If I type in a as student, we'll notice that right away, even without, I just put pass inside of my code inside of class as student, but you'll see here that because I'm inheriting from human, we'll get the constructor from the human class. This is actually referencing what's up here. So we're saying, oh, you want a hair color and an eye color, right? Because that's what the human class wants as well. So this is where inheritance is really powerful. Now, what we can do here for our class for student is I can essentially say self, and let's try to experiment a bit with what's going to happen here. If I have myself, and let's just say that some of the attributes that I want inside of the student, maybe I could put age as a student, so self.age, and maybe I could also make another one where it's like self.year, maybe something like the year to graduate, or if they're a freshman or a junior or a sophomore. And what I could say here as well is I'm going to provide an age, which is equal to, let me default the age to 21, and let me default the age of year to, let's say, senior for the time being. And what we could say here as well is I'm going to say self.age is equal to age, self.year is equal to year. And if I run this code, let's see what happens if I run this code here. A is equal to student. Now, let's go ahead and see what happens if I type in a.haircolor. We'll notice that I'm getting this attribute error that I have no attribute hair color. So this is a bit odd because we thought we inherited from it. What we need to do if we ever inherit from another object is actually call our parent's constructor. So how do I call my parent's constructor? The way you're going to do it is you're going to say, okay, well, grab my human dot underscore underscore init underscore underscore. So this is saying grab my parent's constructor and pass to it my current object and whatever else is going to be in that constructor. So let's experiment really quickly. If I just call this self and I try to make a new student, and now if I have my new student made and I say a.haircolor, we'll see that I'm actually getting brown. And why is this working for me? Well, because when I call a constructor by itself, very similar to what I did in my code when I say b is equal to human, this is essentially the exact same snippet of code. So this is the exact same as what's here. And so because I'm calling it by itself, I'm actually calling it with the default value. So now, not only do I have a student, let me delete this real quick. I now have this a.student. What can I do with my student? I can get my student's hair color. And if you'll notice here, my class doesn't have anything to do with hair color, but where's hair color happening? From my parent that has that attribute there. So why is inheritance important? Well, it's important because you can really cut down on the amount of time it takes to make your code, and it can really make it easier to code in your things as well. Now, be wary that the reason that this code is working without having to do much more outside of it is because I'm using default parameters everywhere right now. So I'm using defaults up here. If I remove this non-default, what will I need to do here? Let's try to experiment. A is equal to student. I'm missing one positional argument in line 29, human.init of self. hair color. So now essentially, let's just say that you want all your students to be to have black hair or something, like straight off the bat if you're defaulting them. What you would need to do down here is provide yourself a hair color for these students. And now that actually fixes my error of hair color, but instead of being brown this time, it's now black. So that's what's happening with my code. Now, this is really easy, like, or not easy, but this is okay for us. But what's the point of us doing this, and what happens more often with inheritance here? Well, what usually happens is that inheritance does we do inheritance because we have something similar that we want to return it a bit differently. So essentially, we have a few similarities in our code, but we want the student to operate a bit differently. And what I'm going to say here is let me set my hair color back to, I'll keep it this way for the time being for us. But let's just say I want to, when I run a student object, let me say A is equal to student. Now, if I print a student, you'll see that I have a human object with black hair and blue eyes, and that's not what I want. I want it to say something that's a bit more unique, right? So you might be thinking, okay, well, do I go up here and change it from up there? Well, you wouldn't want to, right? Because what happens if I change it up there, then every human object returns the same thing. So what we're going to do actually is overload the human operators. And what this will actually do for us is it will tell us if we have it already up there and then overload it down here. And what we could say, one human operator that we have now is just string method. And I could say string of self, like so. And now what I'm going to return down here is student object with blank hair, blank eyes, blank years old, and is a blank, like that. And then I'm going to format it self dot, and this is where inheritance gets really interesting. We'll notice that because I'm inheriting from this parent human, self dot hair color is an attribute that exists inside a student. The same with self dot eye color, the same with self dot age, and the same with self dot year. Now this snippet of code is a bit larger, but I'm going to close it up here. I'll run this guy, and now if I do A, print of A, student object with black hair, blue eyes, 21 years old, and is a senior. Great. And now if I do my normal A, what do I get? My parents' inherited or method where I print out just the canonical string representation. So if you go into your week 2 folder of objects here, programs, excuse me, there's a method down here called animal, and animal contains a ton of information that talks a bit about initializers. For instance, up here we have an init of default language and speak and language, and down here you'll see some more information about overloading that operator and providing it strings. So you can see here, because we're providing it the bird and the language there, it's going to use it for us. But down here as an information, if you're using a default parameter inside of your init for a class that's inheriting from a different one, you could just pass that one into the animals constructor. Let me make this a bit bigger for us. There we go. You could just pass that one into the constructor of the animal class. Cool. Nice. So again, this is in general what inheritance is, and you can see here that we're doing a lot of more coding with self and dots and everything as well. There's a few more overheads that need to be taken into account. But again, please experiment with this. Try to make a class that inherits from student. Maybe you can make it like a art student or a different type of student as well, a computer science student, and then you can continue from there as well.